To rationalize the denominator results, we need to understand the logic of this rule here. And what it basically means is, if I have the root of a, assuming it's a third, then I divide with the root of a again, assuming it's also a third, is equivalent to 1. So just meaning, if I have the root of a as a third and I divide it with itself, then the answer is always 1. Can we justify this rule before we do some examples? So let's say, for example, we have the root of 2. Then I take the root of 2, I divide with the root of 2, meaning I took the root of 2, which is a third, I divided it with itself. So from there, what will happen is this root here will cancel with this root here. And now we are left with the root of 2 divided by the root of 2, which is now 2 divided by 2 because the two roots cancelled. But if you take a number, you divide that number with itself, then the answer is always 1. So here I have 2 divided by 2 is just 1 divided by 1, which is 1. So if you take a third, you divide with itself, the answer will always be equal to 1. We can use this example to rationalize any denominator. In sums, can we try an example? Let's say, for example, you are given this question. Here, you are taught to rationalize the denominator in 4 divided by the root of 2. Of course, the denominator here is the root of 2. So the first step, of course, is to state the rule where we said if we take a third, we divide by itself, the answer is always 1. Here we have the denominator as the root of 2, which of course in this case is the third. So if I take the root of 2 and divide by the root of 2, I expect to get 1 just from how we did previously using this law here. So now that I know the root of 2 divided by the root of 2 is 1, how about if I just take 4 divided by the root of 2, which is the question, I multiply by the root of 2 divided by the root of 2 again, because after all, the root of 2 divided by the root of 2 is 1. So I will not have changed anything in this question because if I simplify this part here, it will equal to 1, and 1 multiplied by 4 divided by the root of 2, it will remain to be 4 root of 2. So I've not changed anything in this question because this part would reduce to 1, and 1 multiplied by this would just remain the same. Then from there, now you see we have the root of 2 here and the root of 2 here as the denominators, and here there is some multiplication. So I can take this root of 2 and multiply with this one first so that I can sort out the issue of the denominator before I come to the numerators. So then it will be the root of 2 multiplied by the root of 2 is just like taking 2 multiplied by 2, and because both have the root, I just put the root. But 2 multiplied by 2 is 4. So now it becomes 4. Then we put the root because we had it here. But you see now it becomes the square root of 4. And the square root of 4 is 2. So then it means the denominators here, once you multiply, the overall it becomes 2. So the denominator are simplified to 2. But you see, we already had the numerators, which is 4 multiplied by the root of 2. So now it becomes 4 multiplied by the root of 2, which is 4 root 2 divided by this 2 after calculating the denominator or simplifying the denominator. So it becomes 4 root of 2 divided by 2. But I know 4 divided by 2 is 2. So these 2 cancels, and here we remain with 2. So it becomes 2 the root of 2. So the answer becomes 2 the root of 2. That is the answer for this question here if you rationalize the denominator, which is the root of 2. That's how we rationalize the denominator. Can we try another example? In this question, we are told to rationalize the denominator 4, 10 divided by the root of 75. So first of all, before we rationalize the denominator, we need to simplify the 75 because it is too big. We can simplify it to manageable values. So what we do is, let me pick first that 75. The first step is I need to find factors of 75. Then, of course, if I take 25 by 3, it will be 75. If I take 15 by 5, it will also be 75. If I take 75 multiplied by 1, it will also be 75. But I want from these factors, I want one which will have at least the highest number with an exact square root. Then the other number doesn't matter whether it has or it doesn't have an exact square root. I just need one with an exact square root. And if we start with the first one, 25, yes, that's an exact square root. 3 doesn't have, so fair enough, we have at least one here with a square root. Then in the second set, we do have 15 and 5, but we see 15 doesn't have an exact square root, and also 5 doesn't have. 75 also doesn't have an exact square root, and 1 doesn't have an exact square root. So the only one with an exact square root at least here is only 25. So I can pick that one here. So I'll go with it. So now it becomes, I can just write 75 as 25 multiplied by 3. Then we put the root because 75 at the root. So from there, I can just expand this and it becomes the root of 25 multiplied by the root of 3 because both inside this root, they of course have the root. So even if I separate them, each of them should go with the root. So now it becomes the root of 25 multiplied by the root of 3. Then from there, we already know square root of 25 is 5. And the square root of 3 doesn't have an exact square root because it is a surd. So now it becomes the square root of 25, of course, we say it is 5. So it becomes 5, the root of 3, because I took the 5 here. I multiply with the root of 3. Now it became 5, the root of 3. So this question here reduces to 10 divided by 5, the root of 3, like that. But now we have not rationalized the denominator, we have just simplified the denominator. So now we need to rationalize it. So to do so, now we go back to the question itself and we say 10 divided by 5, the root of 3, which now will represent the root of 75. And then we multiply by the root of 3, multiply by the root of 3, because here we have the root of 3 and we said from the root, if we have the root of n divided by the root of 4, to a total to 1, so there is nothing we changed here. The root of 3 divided by the root of 3 will automatically simplify to 1. So this part here will simplify to 1. We have done nothing. We have not changed anything in this question. So from there, we can deal with the denominator itself. And the denominator, we have the root of 3 and we have the root of 3. So now it becomes the root of 3 multiplied by the root of 3 for the denominator. So I can take these 3 multiplied by this 3, which is this one multiplied by this one. So 3 multiplied by 3, when we cause both at the root, and just put the root there. So now it becomes the root of 3 by 3, which is 3 by 3 is 9. Then the root because they add the root there. So square root of 9 is 3. So this root of 3 here and this root here, they are simplified to 3. So now we have 5 multiplied by 3. So it becomes 10 root of 3, which is now the numerator. We have 10 multiplied by the root of 3, which became 10 root of 3. Then divided by 5 multiplied by 3, because after simplification, of course, came to 5 multiplied by these 3 here. And from there, we know 5 by 3 is 15. So it becomes 10 root of 3 divided by 15. But 10 is divisible by 5, and so is 15. So if I divide 10 by 5, it will be 2. Then 15 by 5, of course, it will be 3. So they reduce 2 2 because 10 divided by 5 is 2, divided by 3 because 15 divided by 5 is 3, then the root of 3, this one here. So the final answer becomes 2, the root of 3 divided by 3. And that's how we rationalize the denominator results. If there is a place you did not understand, or you have a question, you can ask me in the comment section. I'll try my level best to answer, and bye for now.